Please welcome to the stage, Real Time Live 2018 chair, Jesse Barker.
Well, thanks everybody. Thanks for coming. We have a great show in store for you. For those that haven't been to Real Time Live before, this is one of the coolest things that you can possibly do at SIGGRAPH. Everything you'll see is being rendered in real time, and of course, it's live. I want to thank Roy Anthony, the conference chair, for the privilege of chairing this program and for having the confidence in me to do it. The one other thing that's really cool about what we're going to do tonight is, for the second year in a row, this program will be live streamed over both Facebook and YouTube. So there's going to be hopefully a lot of people other than the large amount of people in this room that are here watching live. I'd like to thank our hardware sponsors, Dell and NVIDIA, for providing workstations and graphics cards for our presenters. I would like to thank my subcommittee, without whom I could have done almost none of this. Everybody's put in a lot of hard work over the last year to get you guys an awesome program to watch for tonight. So thanks to them. I'd like to thank the submitters. People came in force, and I'm super appreciative of that. It made the lives of my jury really, really difficult for a couple of months there in the spring. And I'm sure we all appreciate it, though. And thanks to my jury, who are here tonight and who will be evaluating these presentations as they happen, and we'll be voting live later in the evening. And that's another thrilling thing about Real Time Live this year. It's not just the jury. You, the audience, this is one of the special things about this year. You guys get to be an extra juror. All right, and so here's how this is going to work. Everybody have the conference app? Show of hands real quick. Yes, good. Okay, that's great. So up there you'll see an image of what the Real-Time Live detail screen looks like. The way that you get there is you go to the app. I'll do this with you to make sure that what I say actually makes sense. You click on Favorites, and you go to Real-Time Live. Wait, what do you mean? What do you mean Real-Time Live's not in your favorites? That's just silly. All right, in that case, click on Schedule, and in the upper right corner, you'll see a little magnifying glass. In the search box, type Real-Time, and you'll find Real-Time Live, okay? When you get to when you click on Real-Time Live, you'll get to this detail screen here, and in there, you'll see a poll, okay, which is how this thing is going to work. You'll see a poll that says, "Are you ready for this?" Okay? I want everybody to click on "Are you ready for this?" And you should see three options. There's only one real option in there, which of course is heck yeah. But go ahead and click on that option and submit it. And what I'll do is I'll look at the dashboard that tells me that we're ready. Look at that. There's so many heck yeahs. That's awesome. Thank you, guys. That's your quick tutorial. Later in the program, another poll will activate, okay? And it'll be a list of the 10 presentations you're going to see here. And after the 10th presentation, I'm going to come back up here, and I'm going to instruct you to go into the app and vote for the one that you like the best. And that'll get tabulated. You'll see it live. The dashboard that I'm talking about that you can't see right now will come up on a couple of the screens here. And that's how we'll know my fine 2019 RTL chair is going to tabulate the votes of both the jury and you guys, and then that's going to be it. So that means we're ready for the first presentation, right? And thank you. So first up, we have IKEA Immersed Interior Designer. Presenting are Christopher Baumbach and Sam Boima from DeModern. Christopher started working as a programmer in 1999 and went through several disciplines of software development before joining the gaming industry in 2010. Since 2016, he is working for DeModern and specializes in high-performance real-time graphics. Sam joined DeModern in early 2017, right after graduating in computer science, and specializes in VR and AR applications.
Okay. This is IKEA Immerse. It's a virtual reality interior designer.
Bevor wir starten,
And
bestätige
it's
doch kurz,
currently
dass du
installed
unsere
in Germany
Sicherheitshinweise
in
gelesen hast.
selected IKEA stores, but we're also planning to release that in other countries. So you might be
dem
wondering why
Herz
this is
kannst du
all in
Dinge,
German.
die
So
dir
that's the
gefallen, für
reason we're
später speichern.
currently only
Probier's
having this in
einfach aus.
Germany. We had two major goals
Super.
while developing this. First of all, we
Deine
needed a
neuen
very
Nachbarn
simple
schneller.
and
Hilft
easy
es
to
gerne, dich
understand and
einzurichten.
also joyful
Hey,
user
schön, dass du da
interface.
bist.
So we're using a very simple gaze interaction scheme, as you can see right now.
Schauen dich und
For
richte dich ein.
locomotion, we're using also a very simple teleportation system, which is, again, something users will understand pretty much immediately. And even though it's very simple, that doesn't necessarily mean that this was the first idea we had. We tried many different things, but at some point we agreed on this solution for this. Because 7-year-olds have to be able to use this, and 75-year-olds have to be able to use this because it's completely unguided in the IKEA store. So that's the reason why we went for this solution. The second major goal was
Frühstück ist mein
very
liebstes
top-notch
Essen. Alles ist
photorealistic
ruhig,
graphics
immer
in
still.
VR, which you can imagine is not super easy to do with like current hardware. So we put a lot of effort into all the materials that you can see here, like translucent plastics, glass, certain kinds of fabrics and cloth. So any kind of material like velvet kind of materials are always very hard to do. And the standard shader of Unity doesn't really give us exactly what we needed to give that kind of quality. So we put a lot of effort into that. Another thing is also the lighting. So we use a very interesting mix of static lighting and also dynamic lighting. So we have emissive materials and also dynamic light sources. But because we wanted to have very crisp shadows and really real-looking light, we use the multiple sets of light maps that we can actually blend dynamically. So you can actually say that we
Oh, du
take
arbeitest zu
static
Hause?
lights that we
Würde ich auch
made,
lieber.
and we
Aber
made them
ich
kind of
finde da
dynamic, right?
irgendwie
So
keine
it actually looks way more flexible and way more dynamic that you would expect it from a
Toll,
like
du hast
regular
einen
statically
Gast.
baked
Als
scene.
Babysitter
What we
kannst
also
du
have in here, you
bestimmt
can
gut
see that right
Turnaround.
there, is very playful elements. So what we also want to do is make people play, and they actually like it. And we did a lot of user testing, and so we added some more stuff you can explore. And you also got some other micro-interaction things we will see in a minute. One key feature also, and that shows off the cross-blending between static light maps, is you can freely choose the time of day. It will either happen automatically, unless you choose it by yourself. So Sam just did it by himself. And you can also turn on the lamps. And so what's happening there technically is really a cross-blend of different static light maps that are dependent on the lamps, on the light that's coming from the outside, and also the TV that you can see right there, which is another dynamic lighting element. So we had to make everything blend well together, right? Another thing that's very hard to render usually is glass, so you can see that right there. We did our very best to make that work. So we introduced something that we call thickness maps. So it's some kind of extra texture that tells the computer like how thick the material actually is, so that we can deal with refraction and other features that glass has. Same goes for the plastic chairs. We have some pretty sophisticated shader for that to really solve that problem of certain kinds of refraction. Yeah, you can see that right there, I guess. The candles also is another nice micro-interaction element. You can also extinguish them, and we added some nice particle effects to make the smoke, right? And yeah, that's just something we pay a lot of attention to, because we think detail is absolutely crucial to make the experience really feel real. And we also think that a material is just right if you know immediately what it would feel like just by looking at it. And that's pretty much like the benchmark how we try to design our materials. So as I said in the beginning, this is only available in IKEA stores currently. We're also planning to get it to the Oculus store, maybe also Steam. We're working on it. So you might think this is probably a one-time experience, but we actually have another feature for the customers so that they can take something home. And then I will just toss it over to Sam, and then he will tell you some interesting facts about that panorama.
Sure, so when you're done, you can wait for a second and you'll be presented with a QR code and a URL you can enter on your phone. And I'll just do that, so it's 16QW. And this will be rendered on the server live and will generate a panorama, so a 360 image of your room that you customized, and will also show different items you selected and you favorited down here, and you can just press on them and go to the IKEA store directly and order them online.
Right, that's IKEA Immerse. If you want to try it out yourself, you can swing by the other building in the Immersive Pavilion and check this out by yourself. And who knows, maybe it's going to be available in your country soon. Thank you very much.
Thanks, guys. That was really cool. I like that one a lot. Next up, we have Wonder Painter, Turn Anything into Animation. Presenting is Shang Chao from Xiaoshanyu Creative Technologies. Shang Chao is founder and CEO of Xiaoshanyu Creative Technologies, a company that focuses on creating playful technologies to help everyone express their own creativity. Shang had his PhD from University of Toronto and did 10+ years of research in intersection of computer vision, computer graphics, and human-computer interaction at Microsoft, Lenovo, and the University of Cambridge. Shang?
Thank you, Jesse. Oh, ladies and gentlemen, there was actually a fairy tale from ancient China about a boy who really loves drawing, and he got this magical power. Whatever he draws turns alive. Who doesn't want that kind of power, right? And now, with our Wonder Painter technology, we are turning that fairy tale into reality. And I'll show you how. So here I got just a normal pen and a normal drawing board, nothing special about them. And I just go ahead and draw something. For example, a little horse. And abracadabra. Well, of course, it wouldn't be very magical if all I can draw is horses, so I'm gonna try something else. Let's do a caterpillar. And I'll add some red dust just to make it more dangerous looking. And there you go. So it's not only about drawing. I got this Play-Doh. Credit to my 4-year-old son, and I'll try that as well. So as you can see, we are using some machine learning techniques to figure out what I'm drawing and making the 3D model, and also figure out the best animation for it. And it's not, the scenario is not only about the freehand 3D drawing, and you can actually also make it into interactive game. So now I'm gonna draw a little fighter and turn that into something I can control in the game. I'll try my best to make it look as scary as possible. I guess that's the best I can do. And now, so that's actually developed using our SDK. You can actually making all kinds of action games where all the characters are made by the user themselves. And finally, this can also be used as an interactive media for storytelling kind of applications. Here.
Welcome to the world of Wonder Painter. Let's draw a hero for our wonder journey.
So as guided by the program, I one by one draw all the characters I needed in the story. And everyone can have their own version of the story, even if it's the same script.
Uh-oh, a big rain cloud comes. Draw something to keep him dry.
And again, I'll not use drawing, but use some Play-Doh. Actually, there's other things I could use, like Legos or toys, or even origami. So for now, I just use this one.
Thank you. Oh no! This place is getting flooded.
And our algorithm is actually quite
him.
open-ended, so it gives you lots of creativity space. So now I'm going to ignore what it tells me to do. I'm going to draw something completely different.
Thank you for saving my life. Let's keep moving. He sees a land ahead. That's a bit too high. Draw a bird to pick him up.
Okay, I don't know if this qualifies as a bird, but
Great. Where is our next destination? Create it yourself.
so that's Wonder Painter. We're actually making this technology available, so including the authoring tool for you to create the script yourself, the SDK where you can develop your own program based on, and also a web service you can experience in the web browser. And I hope you enjoyed Wonder Painter. Thank you very much.
Thanks, Shang. That was really funny. Next up, we have case study, Neil Blomkamp's Atom Episode 2 short film, a VFX workflow for real-time production with photogrammetry, Alembic, and Unity. Presenting are Abhishek Joshi from Oats Studios, John Parsay from Unity Technologies, and Mike Wetherick from Unity Technologies. Abhishek is a CG supervisor and lead artist at Oats with a distinguished career in the film industry. John is a graphics engineer on the Made with Unity team, focusing on shading and lighting technology, and Mike is a senior technical producer on the Made with Unity team with a long career in the games industry. Take it away, guys.
Hello. Mike's just going to play a clip from our short film. So Oats is a pretty tiny boutique studio. Neil started it as a creative playground. And we use a lot of traditional VFX tools and techniques, but due to our really small team size and lack of render resources, we're always looking to push efficiency wherever we could. So for assets and animation, we're always using photogrammetry extensively, and motion capture and performance capture. And for rendering, pretty early on, we had to switch from CPU-based solutions to GPU ones. But when we started trying to do full CG stuff, it was still a goal for us to try and get something done in real time, which is why it was a perfect match when Unity and us decided to team up to make the Atom sequels. So our goal with it was to always just get real-time rendering, working in 30 frames per second, and looking as photorealistic as possible.
So as you can see, this is the executable of the short that you may have seen on YouTube. And at any point, we can just pause the camera, zoom around. It gives you a very dynamic way of viewing the content. I'm just going to scrub forward to a later scene here, and we can talk about some of the tech that we did for this particular character. So when we first started working with Oats, achieving photoreal was a really big sort of bar that they set, and we tried to tackle that with a whole range of different techniques. We used Alembic for streaming in cloth. They did Dye4D face capture for a lot of the performance capture. And then we brought it in, and this is just the off-the-shelf Unity version that we used. And this character here, the mirror, has a whole ton of interesting tech that we packed in that John is going to talk about here. So I'll just fast forward a little bit.
Yeah, thanks, Mike. So yeah, well, we thought with like the 5 minutes that we had up here, we'd want to talk a little bit about this character, the mirror here. A lot of interesting stuff was put into this character, and we thought we would just dive into the editor really quick to take a closer look at some of the things going on. So as Avi was mentioning, one of the things that Oats did a lot was a photogrammetry workflow, and that actually started with a costume designer creating physical costumes in the back of Oats Studios. And when we scanned that and brought it back into the engine, we actually rewrote a Silk BRDF, the Kajika BRDF, for the Silk of the mirror. We also took advantage of an implementation of a screen space subsurface scattering with Burley's normalized diffusion, with a diffusion profile that an artist could interface with to control how light was diffusing through the skin of the mirror. And you'll notice that regarding the eyes, and again, as Mike was mentioning, we took advantage of Alembic to stream back more than just the cloth, but also the facial performance of the characters in the Atom shorts. But we actually composited that with this Alembic stream with a tessellation interface for actually Avi here to work with to converge towards a final look that the film shipped with. Now, this is actually starting with what the film shipped with, but you could see that there was really infinite permutations for us to work with and for us to play with the mirror here to ultimately come to what we ship the films with. Yeah, this is just some of the lengthy array of stuff that we put into all the characters on the shorts, and we're really happy to talk about it with you guys while we're here. Yeah, thank you for your attention.
We are doing a deep dive as well for one with Autodesk and one with Unity. It's tomorrow at 11 and 11:30. Yeah. Anyways, thank you.
Thank you so much. Thank you.
Thanks. I always get tricked by that when I see it, and I think it's a video until Mike whips the camera around, and then everything's clear. Next up, we have democratizing mocap, real-time full performance motion capture with an iPhone 10, Xsens, iKinema, and Unreal Engine. Presenting is Corey Strasburger from Kite and Lightning. Corey is the co-founder and creative director of Kite and Lightning and a two-time Emmy Award-winning and Cannes Gold Lion-winning visual effects artist. Since Kite and Lightning's inception in 2013, Corey has creatively directed the studio's content creation focus, producing virtual experiences for NBC, Lionsgate, HBO, and the original virtual reality opera Senza Peso. Their latest venture, Babylon Battle Royale, is a satirically rich social VR party brawler game which takes you into an unexpected future where immortal babies battle for fans, fame, and fortune. Corey?
Am I live here? Thank you, Jesse. All right, guys. Well, I'm very, very excited to be here and show you guys a really cool real-time mocap setup that I've been working on that I think has a lot of potential for bringing virtual characters to life in a very easy way. And so to help us out with that, I got Maniacal here. He's one of the wild and crazy immortal babies from our up-and-coming game called Babylon. Now, this setup's based on 4 pieces of off-the-shelf technology, all working together in real time to create everything that you're seeing right here. So we got an iPhone 10 strapped to a $40 paintball helmet. That's doing all the face capture. We got this really cool inertia-based full-body mocap suit by Xsens that's capturing the body. And then we've got the Unreal Engine that's basically hosting the whole setup as well as making everything look super beautiful. And lastly, we have iKinema Live Action, which is working in the background, doing a bunch of tuning and retargeting magic to the body data in real time. So let's dig in, starting with the iPhone 10. Now, this is basically like, Memoji technology that's driving the face capture. And it's all available through ARKit. And Maniacal here is pretty much based on the 51 blend shapes that ARKit can drive. And as you can see, there's a pretty good amount of expressivity that you can achieve with these 51 blend shapes. Like, yeah, baby, what's up, SIGGRAPH? Or I could get really medieval on all y'alls. Yeah. Oh my God, I'm so afraid. Ah! So anyway, it's not bad, it's not bad. And and there's some other really great features with the iPhone tech. So all the data that you capture can be easily used for other characters with the same setup, like this crazy Yeti mask. Yeah, what's up? So that's pretty cool. And then you can easily slap a microphone on the bottom of the iPhone, and then you got yourself a super portable facial capture setup that's super easy to use. Okay, you don't need dots on the face. You don't need to train to the actor's face, though I'm pretty sure if you do, it'll improve the final result. And you don't even need a helmet. You can actually get a solid capture just hand-holding the phone. You can also stream into the Unreal Engine like we're doing here, and they've got all that stuff built in and ready to go. Or you could capture it locally to the phone and then import it into other things later. So a lot of really easy to use kind of features. Now this is where the whole setup gets really exciting because both the iPhone 10 and the Xsens suit can stream into Unreal over Wi-Fi. So we have the entire range of Wi-Fi as our capture volume. And then you can set this up anywhere, no matter how big or small the space. Now, my favorite thing that I'm really excited about is that you can very easily add other performers into the same capture space, all streaming into Unreal. And then in Unreal, all you have to do is press record on their sequence recorder, and it'll capture the whole shebang, right? Every actor's body, face, and audio right into a sequence ready for playback. So that's super awesome. And literally, I was like almost hours away from showing you guys moving fingers in this whole scenario too, but sadly, you guys are stuck with, dead hands. But that's it. That's the easy part to integrate in all of this. So that takes us to the final piece of this real-time puzzle, which is iKinema Live Action. And it's basically doing a really amazing job at retargeting the character to the performer, but it's also handling things like foot penetration and foot slippage, and even inner body penetration, so that you don't inadvertently kind of like shove your arms into your giant character's head or body, which was something I was doing a lot early on, and then I'd have to go back into Maya and clean it all up. So it's a very welcome feature for this setup. And so collectively, we basically have like a really cool mocap setup that's really, really easy to use. And it's pretty good looking, it's not bad. And the fact that it all runs in real time, and as you can see here, you couple that with the insane rendering of Unreal, and you could literally just stream this stuff like we're doing, or render out final rendered character content, which is pretty amazing. And it's still blowing my mind how good these babies look in Unreal compared to my software renders. So high five to those guys, because I cribbed all of their shaders and eyeballs and lighting from their recent Mike Seymour digital human scene. So thank you guys for giving that stuff out to all of us. So anyways, that's it. We're really excited to actually start using this ourselves, because we've got a bunch of immortal babies to bring to life for our game. And now we have a really cool way of doing it. So thank you guys. Peace out, everybody. Yeah!
Thanks, Corey. I don't think I ever picked up that you were dancing on a bearskin rug there. That's pretty cool. Next up, we have GastroX, real-time interactive fluids and soft tissues on mobile and VR. Presenting are Sam Glassenberg and Andy Saya from LevelX. Sam is the CEO and founder, and Andy is the development lead. These guys have spent their careers in the games industry at places like LucasArts, Microsoft DirectX, and Phosphor Games. Now at LevelX, they are unleashing all that tech and know-how on unsuspecting doctors, including some novel real-time fluids and soft body approaches. Take it away, guys.
All right. All right. So at LevelX, we make video games for doctors. And these aren't games that teach you how to be a doctor, or these aren't games for wannabe doctors. They're for professionals. And so to do that, we really need to capture the challenge of surgery. Not the boring scenarios that you'd see every day, but the rare, once-in-a-lifetime, adrenaline pumping, oh my God, what the hell is that? Doctor, fix it or the patient's gonna die scenarios. Like this physics puzzle, where a carpenter was holding some nails in his mouth, and he breathed one in, and it punctured his bronchus. And so to capture this, we really need to solve some classically hard visual effects problems, like 3D fluids. In this case, we've got obviously some highly viscous fluids. We've got mucus rendered as a ray-traced signed distance field, refracting the scene and blended into the environment perfectly against the depth buffer. And everything that we do is not only running in real time. To make the problem even harder, everything we're showing you here, Andy is playing off of an iPhone. And literally everything we're showing you here, you can play on your own device. Just download GastroX from your favorite app store. So yes, this is the large intestine. So here inside the butt, we're surrounded by this totally interactive soft tissue environment. Literally everything moves. Our GPU-based relaxation solver, it's global, so you can see as this moves and interacts with the tissue, you can see it even affecting tissue at a distance. I can press this semi-rigid wire snare along the surface. I can push down these ridges, and I can take my forceps, and I can literally grab any tissue that I want. And as I pull it toward the camera, you can see the subsurface scattering from this super strong LED that's right next to the lens. So I'm going through and I'm playing what seems like a really tough hidden object game. I gotta find all the precancerous polyps. They hide behind ridges. We're gonna remove that one right there. And so we pull it off, and holy crap, there's a blood vessel hiding underneath it. So now I've triggered a massive bleed 3.5 meters inside the 3.5 feet inside the body. So now you can see another one of our GPU-based fluid solvers in action. The 3D blood totally interacts with the soft tissue environment. It fills, it overflows the valleys. As I move around the blood, it flows realistically. So now I've got a physics game. I can use this high-pressure water jet that Andy's using to spray away the blood long enough in order to identify the source of the bleed. You'll notice the fluids, they all mix realistically. The blood actually has different scattering parameters than the water. water. So to seal the bleed, I'm going to deploy my Argon Plasma Coagulator. It's just like a plasma rifle in a first-person shooter, only it's actually real. Surgeons use these all the time. Yeah. Too much damage. Too much damage. Too much damage. So what we're showing here, these sims are literally all running in mobile GPU pixel shaders. All the source data is stored in texture. We have this moving simulation front that moves along with the camera. The environment itself is this canonical tube that we displace with multiple overlaying displacement maps that we blend using programmable blend hardware in really interesting ways. So as you can see here, I can literally remove, and you can remove chunks of tissue from this highly squishy tumor as we biopsy it. Most games feature characters inside of environments. At Level X, we make games that feature environments inside of characters. So now we're gonna switch to VR. The beauty of having a phone as your target platform is that it's easy to scale it up to high-end VR. So on phones, we're frame locked to 30 frames a second, but on a high-end GPU, we can run at 120 frames a second. It's a little bit bouncy up here. But we can bump up the sim res like crazy to create what is a ridiculously awesome VR experience. Literally, you're surrounded by this squishy, soft body environment, and Andy is literally manipulating it with his hands. So, you know, as you go into surgery as a patient, you don't really realize how doctors actually train. The first time a doctor encounters a rare or difficult or complicated case like the ones we showed you, it's on a live patient, a live human being. That patient could be you or someone that you love. So bottom line is better games and better shaders make better doctors. So the 50-person team behind this, there we go. It includes game developers designers, and artists from LucasArts, Microsoft, EA, Midway, and elsewhere. And we're hiring. Thank you very much.
Thanks, Sam. Everybody okay? All right, just want to check. Just want to check. Okay, next up. Oh, whoops, went too far. All right, next up, ray traced collaborative virtual production in Unreal Engine. Presenting is Gavin Moran, creative cinematic director at Epic Games, Grayson Edge, senior cinematic director at Epic Games, and Mohan Leo, director of immersive content at ILM X Lab.
That's a tough act to follow. So I'm Mohan. Tonight, Grayson, Gavin, and I are going to be showing off some of the production techniques we use to create a real-time ray tracing demo we call Reflections. That demo is playing behind me right now in real time in Unreal Engine. I'm going to enter Unreal Editor in VR mode and join Gavin and Grayson in the set we used to create this demo. There's Gavin.
Mohan.
He's wearing an X-Sense mocap suit. He'll be playing one of our stormtroopers tonight. He's also in VR, so we can see each other. And there's Grayson.
Hey there, guys.
He's using Unreal Editor in desktop mode. The three of us will be working together to reshoot and adjust a moment from the demo in real time. We'll also bring up a live ray traced view so you can see final picture quality as we work. So, Grayson, let's call up the existing performances and cameras.
Okay, you got it.
When we first created this demo, Gavin played all three characters himself, layering mocap one after the other while in VR, which is really cool because it means he could basically perform against his own performances as if he's standing next to them. We'll show that workflow right now by reshooting just one moment for this trooper right here.
All right, the tall white one.
So Grayson, let's scrub to the part where we first see Phasma, please.
Sure.
So Gavin, when this trooper turns around and notices Phasma, this time around, let's try a bigger reaction than last time.
Okay, bigger.
Grayson, let's play back the old performance.
I heard Kylo Ren destroyed the one over in D sector. If you ask me, who's ever in charge of this place should be transferred to Hoth. What?
Okay, got it.
Got it? Cool. Let's rewind. We'll hide the old performance.
Okay.
And let's give a mark for Gavin to start on. Cool. Let's get Gavin into costume, please.
Oh, well, that's pretty cool. Look at that.
And I'm going to set up a camera here. And we'll just use that as a wide master view for now. We can go and adjust that later after we've recorded the new performance. I'm going to bring up a monitor of the camera we just set up. And I think we're ready to record.
Okay, recording in 3, 2, 1. Recording.
I heard Kylo Ren destroyed the one over in D sector.
If you ask me, who's ever in charge of this place should be transferred to Hoth. What?
And cut.
And cut.
Great. So let's see playback on that.
Okay, you got it.
If you ask me, who's ever in charge of this place should be transferred to Hoth. What?
Cool. So we got that. Gavin, you can hop out of VR if you want.
Thank you.
And now that we have a new performance, we'll tweak a couple of other things. So let's add a light. And we'll put a bit of a rim light on this trooper right here. Just about there. And we'll have another look at our camera. And we're a little bit close here. Do we want to? Oh, we're going to. Oh, I see. Sorry, we're on a 70. Yeah, there we go. So we're a bit wide on this. Let's go closer to 75.
Okay, go into 75.
Cool. And we'll pull focus during the shot from the trooper to Phasma. So let's open the elevator doors.
Okay, you got it.
And pull deep. Great. So we have those two focus points. Let's rewind.
Okay.
And roll camera.
Okay. Rolling in 3, 2, 1. Rolling.
If you ask me, who's ever in charge of this place should be transferred to Hoth. What?
And cut.
And cut.
Great. Grayson, let's drop this new take into the cut.
Okay, you got it.
So in the last few minutes, we recorded a new performance. We adjusted the lighting, and we set up a new camera for a shot. And Grayson's working on showing us that new content now in Unreal Editor in the context of the sequence.
So this was an incredibly fun project for all of us. I'm a huge Star Wars fan, and the ability to step into VR and in Star Wars and record multiple performances was just a dream come true.
And obviously, making content like this, takes a whole really talented team. There's a bunch of them right here. And the nice thing with the multi-user functionality is that a whole team of people can work together in the same scene at the same time, just like we do on a film set. And that multi-user functionality will be available to everyone in an upcoming release of Unreal. One more note about the ray tracing. When we first generated this content in the spring, it was running on an NVIDIA DGX workstation with 4 Tesla 100 GPUs. But the ray tracing you saw today and the sequence you're about to see is running on just one NVIDIA Quadro RTX. Grayson, how are we doing?
I think we're good to go.
Let's see it.
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector. If you ask me, who's ever in charge of this place should be transferred to Hoth. What? You think she heard us? Yeah, I think she heard us. At least we blend in for once.
All right, that's the end of our demo. Thank you.
Thank you. Good night. Thank you.
So let that be a lesson to you when you're going to talk about somebody behind their back. Make sure they're not behind yours. Next up, all right, the power of real-time collaborative filmmaking. Presenting are Jean-Colas Plunier, Stéphane Taïeb, Ivan Remekel, Armel Bauer from Pocket Studio. Jean-Colas has over 25 years of experience in the animation industry and digital special effects. Over the past 3 years, he's been working on the development of real-time software for the production of movie content. He's the founder of Pocket Studio. Prior to joining Pocket Studio, Stéphane worked on large C++ code bases, such as Seagal 3D Mesh Generation Package, or LumaScaf's software suite designed for photorealistic real-time rendering of CAD data. Ivan previously worked at LumaScaf on photorealistic real-time rendering of CAD scenes and at Imagination Technologies as an OpenGLES driver developer. His interests are real-time rendering and anything Vulkan-related. Armel received her doctorate degree in 2017. Her thesis, entitled Living Book of Anatomy, was about studying anatomy in motion in real time. Her interests are animation, virtual humans, and mixed reality technologies.
Thanks a lot, JC. Howdy, and good evening, SIGGRAPH. Less than a year ago, the four of us started to work on real-time, obviously, Vulkan-based unified workflow that allows a user with a modern and intuitive UI to actually create an entire 3D movie, animation movie from beginning to end within the same application. So this is what we call a unified workflow. But what primarily differentiates this solution from most, if not all, current DCC tools is the fact that this application, this solution, is actually built to have a real-time, so far so good, collaborative editing workflow. So not unlike Google Docs, right? So several people can actually work on the same project at the same time and see each other's changes in real time. So we call it Pocket Studio because it's literally like having a studio in your pocket. And thanks to SIGGRAPH, we would like to show it to you today for the first time. The goal of the demo is to create a short movie together using 3 computers and 1 smartphone connected to an external Google server that is located in Seattle. So we work in real conditions. Even though we are the 4 of us in the same room, we would be 200 miles apart from each other. This would make actually no difference at all. We are now going to walk through what a seamless, user-friendly, real-time, collaborative, unified pipeline, I know it's a mouthful, is like. So we can log in. The first thing, so to explain you a little bit of a setup, on the left screen, in red, you will see, so each one of the big screens here will mirror one of the computers we have on the stage. So on the left, you will see the screen of Stéphane in red. In the middle, in green, you will see the screen of Ivan. And to your right, you will see in blue the screen of Armel. Sorry. So the first thing Ivan is going to do, in green, in the middle, is to create a movie project from scratch. And he will share it with Armel and Stéphane. So now they can actually work on this project together. For example, Stéphane could change the title of the movie. For example, RTL SIGGRAPH, sounds like a good name. Armel could actually drop a movie poster onto the project's card. And Ivan, in the middle, could create a 3D scene. In which Stéphane could import some geometry, and Armel could import an animated character. So as you can see, the geometry is actually not in the right position. It's intentional. We want to show you what happens when several people move geometry in the same scene at the same time. You can also see that when an object is selected, it's actually highlighted with the color of the user who selected that object. The only way you can actually keep track of who is doing what when everything is so seamless is to use that kind of color scheme. So the layout looks cool. In the next step, we're going to create cameras to create our first sequence. So to speed up the process, Armel, Stéphane, and Ivan are going to create a camera each. So they're working the same scene, and they can all at the same time create as many cameras as they want. Great. So now we have actually 3 cameras. We're good to start editing. So Ivan, in the middle, is going to start editing a sequence. And Armel and Stefan, at the same time, are going to keep working on the scene. They're going to drop materials onto the geometry, and they will also do some lighting changes. So I just want to be super clear in this part of the demo. Ivan is editing a sequence, and at the same time, Stefan and Armel, left and right screen, are actually making changes to the scene that is being used in that sequence, right? And Ivan, who is editing the sequence, can actually see the changes that are made to that scene by other people seamlessly and in real time. So right now, Ivan is finishing the cut. And as you can see, the Armel is still making some lighting changes. It looks great. So now let's say we want to add another shot to that sequence, but using a different scene. Right? So this time, Armel is going to create that scene, and she will insert it into the sequence. And so what I want you to look at is the top right corner of Ivan's screen in the middle. You will see that as soon as Armel inserts or creates the scene, it will actually show up into Ivan's sequence editor. Here you go. And and now if you look at Ivan's timeline, you will see that as soon as Armel inserts the scene into the sequence, Ivan's timeline will be updated in real time as well, instantly. So you can see in Ivan's sequence editor right now, the clip that Armel just dropped is selected is highlighted in blue as well. This is very cool. So one of the benefits of actually working with the cloud is that all the different scenes that we created for that project are now actually stored on the Seattle server, which means that we can actually access them and film them with a phone using augmented reality. So I'm going to show you an example of that. We need to switch to the phone here. Pocket Studio comes with augmented reality application. I'm going to start it. The first thing it's going to do is to present me with a different list of the different scenes that we created for the scene. So I'm going to use this one. Currently, the phone is tethered, because that was the only way we could actually have the screen projected onto the theater screen. So it uploaded the data from the server. I'm going to drop the geometry on the scene. I'm going to zoom in a little bit. So I'm not pretending I'm Spielberg here, right? So bear with me. Now I'm ready. I'm into a ridiculous position. That's normal. So imagine now you are at the airport in Los Angeles waiting for your plane, and then the director doesn't know what to do. He can pick up his phone and start filming. All right, that looks pretty cool. I like this. So now the camera that I just recorded we can switch to the other screens. Yeah, great. The camera I just recorded is actually stored on the Seattle server, which means that Armel and Ivan can access it straight away, right? Currently, you can see that the camera is a little bit shaky. So Armel, why don't we smooth it out? We can actually add a little bit of weight to it. We can filter it out. What I want you to see is that as soon as Armel makes a change, the camera of Ivan is actually updated. So in the middle, it's updated in real time instantly. Great, this is a great camera. So maybe, Ivan, we can go back to the sequence and then use it in the third shot. That's awesome. Okay, now another benefit of actually having an application, DCC tool running in the cloud, is that we can actually render the movie live stream, render the movie live in real time on the server, right? Using the same kind of GPU we have in these machines. And we can stream it and watch the movie live on the phone. So for that, I'm just going to use a very simple live stream app on my phone. It's going to connect to the server. And here it is. I have my movie on my phone. So you can watch it from wherever you are. And remember that we're actually rendering this movie live on the server in real time, which means that we can still make changes to the film project and see the result of those changes on the phone as we speak, right? So Stefan and I are going to show you a couple of examples of that. Stefan, why don't we drop a different materials on the ground. Here it is. And you know, I don't like this character design. Maybe we can try something else. And now in the movie, I have a different character design. So anyone who works in production knows that if you have a hero character in 1,000 shots, and then you need to change it, it's a pain. With this kind of technology, in a click, you can actually see a completely different version of your movie almost instantly. I think this is really cool. All right. So now, while Stefan and I were busy with the streaming demo, Armel and Yvain kept working on the movie. So what I propose to do to conclude this demo is to watch the final results. So now our movie has 2 sequences. And great surprise, we'll show you this movie rendered using ray tracing in Vulkan with NVIDIA's RTX technology. So what you're looking at here is a movie being rendered in 2K in real time. So we're rendering ambient occlusion on one single GPU. So it's really interesting because when you have the transition, we're actually rendering 2 2K images at the same time in real time. So for us, the future of filmmaking has at least 4 components. It's about real time. It's about unified pipeline, because the unified pipeline doesn't break the creative flow. It's about being able to use consumer device to enable people who don't necessarily know how to use complex DCC tools. And it's really about collaboration. And we hope with this first public display of Pocket Studio, we gave you a glimpse of the future of both production and how we will distribute and consume 3D animation content in the future. Thank you so much, guys.
Thank you. That seems like really powerful technology. And I love the shirts, by the way. Next up, we have Mixed Reality 360 Live, live blending of virtual objects into live stream 360 video. Presenting are Tae-Hoon Lee, Ian Lowe, Lohit Petakam, Stephen Thompson of CMIC, Victoria University of Wellington, and Dreamflux. Tae-Hoon James T.J. Lee is a professor at Victoria University of Wellington, New Zealand, and a deputy director of Victoria University's Computational Media Innovation Center, CMIC, a new institute for research and commercialization, and a founder of mixed reality startup Dreamflux. Previously, he spent 17 years at Samsung as a principal researcher leading computer graphics and mixed reality research. TJ is also the chair of this year's SIGGRAPH Asia Virtual and Augmented Reality Program. Ian is lead designer at Dreamflux, previously at Swedish design studio Kram Weishar. Lohit Petakam is a computer graphics PhD student at Victoria University, previously at 8i, intern at OLM Digital and Weta Digital. Stephen Thompson is a computer graphics master's student at Victoria University, previously intern at Weta Digital.
Thank you, Jesse. Hello, everyone. I'm TJ, and we are Dreamflux and CEMIC from Victoria University of Wellington, New Zealand. Ian is watching 360 video of Wellington in VR headset. It provides immersive watching experience and sense of telepresence, but user interaction is limited by head rotation. Dreamflux augment virtual object into 360 video in real time to provide illusion to interact with scene object. This is conceptually augmented teleportation. VR user can be teleported to the captured remote place, and Dreamflux augment scene object interaction. In order to keep the high presence of a virtual object into the real-world scene, the quality of lighting and blending is very important. Dreamflux provides a real-time solution. Our toolkit for studio artists is ready. Lohit will introduce MR360 toolkit.
Thanks, TJ. Hi, everyone. I'll be going through our toolkit in Unreal Engine 4. So without our technology, in a manual composite, we'd probably use static, unoptimized lighting. However, with our technology, we can seamlessly augment objects, even in dynamic scenes. Can we switch to the laptop view? Great. So here we can seamlessly augment objects, even in dynamic scenes, so that artists can focus on building experiences rather than manual compositing. So let me switch to a bit of material to preview our lighting. So here we've got our image-based lighting, which is made real-time for video. However, ambient lighting alone isn't enough to match strong dominant lights in the video. So what I'll do is I'll turn on light detection, and now we can recover high-frequency lighting and shadows that much better match with the video. And for the case when I want to put this robot in like a specific point on the video, these shadows really help to provide a much better sense of blending. And we can even preview what the light detection is doing. So, so we can, sorry, I'll just wait for this to just finish. So here we have the main dominant light, which is the sun. And if we can preview the light mask that's being detected in real time. From these patches of light, we extract shadow features such as softness, direction, and intensity, so that we can match our virtual shadows with the real world much better. And because we integrate with Unreal's drag and drop workflow, we can really simply add existing assets to start building scenes really quickly. And because we operate on the fly on low dynamic range, conventional 360 video, without any pre-computation, we can even adapt the live stream. And let's switch over to Ian now to show an example of this.
Thanks, Lohit. So we didn't bring a booth this year at SIGGRAPH. So I thought it would be really fun to design a virtual booth in real time just for real-time live. So how are we going to do this? So I'm over here physically on stage, but our booth is being set up right over there by Lohit and Steven, my colleagues. And so what we've done is that we've set up a Samsung 360 round camera in the middle of the booth, and that's streaming to this PC over here and into my headset. And that's going to allow me to teleport over there and see what my colleagues are up to and see if I can help them out. So what I'm going to do is, can we switch to my computer, please? Thank you. So I'm going to put on my headset now. All right, so this is where we left off. And I'm going to teleport over to the virtual booth. Oops, wrong one. Give me a moment. Awesome. So you can see that it's as though I'm in the virtual booth with Steven and Lohit. So looking at the booth right now, it's a little bit empty. So what I'm going to do is add a few objects to kind of add to my video. So we're going to have a table, we're going to have a chair, we're going to have a little real-time live object, and some plastic materials. Oh, yes, and also we need a banner, and special thanks to our sponsors, Samsung and NVIDIA, for helping us out. So you can see that it doesn't look too bad. With our lighting solution, we're able to naturally blend digital objects into the video. And so as a designer, it's really easy for me to more accurately pre-visualize what I'm trying to do, as well as keeping immersed in my task. So obviously, this is a virtual booth, so we don't have to stick to regular objects. What we can also do is add something more interesting. So we've traveled all the way here from New Zealand, so it would be a shame if we didn't bring some New Zealand flair over here. So I'm going to add a couple of ferns to the scene. Awesome. Got a log. Ooh. Yeah. And of course, we need a booth mascot, so here's a kiwi bird. Awesome. OK, so basic layout is done. I'm quite happy. We need to change the lights, though. So, OK, Steven, can you turn on another light, please? And can we get a yellow color going? Awesome. All right. So you may notice some latency here. And that's something that we're working on. And we hope to improve with future software and hardware updates. So hey, guys. Anyway, so I think this is really good. And since we track our lights in real time, we're able to also do some interesting effects and interactions that are based on the things we based on changing lighting conditions, such as decorating a light with our favorite conference logo. Oh, Lohit, can you bring the light closer, please? Yes. Closer? Thank you. There we go. Awesome. And our keybird is also getting a bit excited. Awesome. So this booth looks great. I'm very happy, and I hope that you guys also had a good time looking at this booth, and it sparked your imagination of what you can use our technology for, and I'll pass it back to TJ.
Thank you, Ian. You did a very great job, so you need some break. So please teleport to Wellington and take some break at the beach.
Thanks.
So I think the application area of MR360 Live is wide. So if we can connect with a high-speed network like a 5G, we can teleport to any place in the world, like a live sports concert, and even a live event like a real-time live, and we can jump onto the middle of the movie scene and interact with the scene object. If you are a studio artist, producer who are seeking for a new way of immersive and interactive storytelling, please contact DreamFlux. We can light your dream. Thank you.
Thanks very much. I actually can't wait to go to Wellington now. So next up, we have virtual production in Book of the Dead, Technicolor's Genesis platform powered by Unity. Presenting are Veselin Efremov from Unity Technologies, Francesco Giordana, Callum James, Adam Davis, Girish Balakrishnan from MPC, and Gail Soramount from Technicolor R&I. Veselin Efremov leads Unity's demo team, which created the groundbreaking real-time short films The Blacksmith and Adam. His latest project is the interactive film Book of the Dead. Francesco is a principal software architect at MPC with a long career in both games and VFX, focusing on the use of real-time technologies applied to filmmaking. Girish is MPC Film LA's virtual production supervisor, working with the Genesis team on building immersive workflows for the future of filmmaking. Adam, head of virtual production, has been at MPC for 12 years and was previously MPC's head of discipline for crowd and motion capture. Callum is MPC software engineer with many years' experience in the VFX industry, specializing in real-time graphics and systems. Gail is a senior engineer at Technicolor Research and Innovation, working on real-time rendering techniques and their integration in production tools, especially for real-time previs, on-set, or in DCC tools.
Thank you, Jesse. So I can't remember even simple sentences, so I'll just read from my phone. So for our internal demo productions at Unity, we use the latest engine features and create experimental projects with them. Book of the Dead is one such project. We set out to make an experience which can be both watched as a movie and played as a game. With real-time technology, films and games are coming closer together, both in terms of what we can make, but also in terms of how we can make it. Francesco and the rest of the team will now show you how MPC's virtual production platform uses both modern and traditional tools to empower filmmakers.
All right, thank you very much, Wes. So tonight, we're going to try and do something a little bit different. We're going to try and shoot a teaser shot for Book of the Dead live in front of you. So this is not a tech demo. This is basically our kit taken from Pinewood Studios from a stage, packed up in a box, shipped over the ocean, and then unpacked in front of you, just at least a portion of it, where we're going to use it to, make some sort of shot in front of you. So first thing, when we have a set, we want to be able to scout it to find a shot. So we're going to go in VR, and Girish will take the lead from here.
All right. Thank you guys very much. We are inside the world of the Book of the Dead. And so the shot that you saw up there, I really liked it, but I have some changes I need to make. So I need a set dresser. Adam, where are you?
Yep, just behind you.
Oh, well, hey, buddy. How you doing? So let's teleport down here, and I think I'm going to line up a shot here with the virtual camera. So take a look over my shoulder.
Yep.
So over here, I'm thinking I like this framing, but it's a little too wide for my taste. So can we bring something in to kind of bring the framing a little bit narrower?
Well, what about this?
Well, okay, come on. Okay, that's a little ridiculous.
Well, you
Put
said
that back.
move something.
Okay, all right. Let's move something a little bit more appropriate.
Tree on the right?
Yeah, that may work.
How's that?
All right. Bring that in a little bit more.
Tell me when.
Lower.
Jeez, directors.
All right, stop right there. Thank you, Vic. All right, so if you come back over here, I think the shot, instead of just starting right here, I want to start right up in the trees. and then maybe crane down a little bit. So can you set a mark for me over here?
Well, somewhere there, yeah.
Yep, that sounds good. And Callum, do you mind playing the animation forward? All right, that sounds good. Can you pause right there? All right, I'm going to boom down. And it would be good to kind of get this and end on this really nice frame right here. So set a mark over here.
So number 2 here.
All right, awesome. So I'm going to get out of VR, but Adam, I need some help later on, so just stay in VR for me. And Callum, do you mind lining up that shot with the crane?
So as you can see, VR could be a very powerful tool to basically explore the space and find your shot. And we want to show how important it is to collaborate in the space. So this is just the start. Now we have a bit of a vague idea of what we want to do, but it's time to bring in the real cameras, the virtual cameras, and actually make a shot. So to do that, we have brought with us a number of physical devices which are all connected together, and then they can be used to control a camera. The reason why we do that is because we want to make sure that a film crew that has worked for many, many years on real sets feels familiar and can replicate the movements that they would use on real cameras to drive virtual devices as well. So I'm going to pass it back to Girish for some testing of the rig, first of all. So Girish wants to use a crane for this shot, but we couldn't fit a real crane in here because it's too big. So what we did, we brought smaller devices, like some pan bars that Girish is moving right now, some wheels that Nigel will move in the corner there, like a focus spot on which you can refocus, and also a little slider over there which will act as a dolly track. So these are just approximations of the real gear we would use, but of course we have to do away with the space that we have. But the idea is that now all these guys, we can work together and build a shot like a real camera crew would do. So back to you, Girish, again, and then let's actually make a shot.
Awesome. So if now that we're lined up right here, I think I'm going to boom up to my first mark, which is right here. Do you mind tilting down for me? And so as we move the camera down, we just need to lift up and let our character pass right by. All right? So let's roll camera.
Speed.
All right, ready? And 3, 2, 1, action. All right, let's cut right there. Can we check the gate?
Gate is clean.
All right. So now, that was a good shot, but I think I had an idea for another one. So what if we do something where we dolly back with our actor, and as she comes back in the frame, we pull back the slider and then lift up the crane. To do that, can we slide the dolly to our end mark? I think I kind of want to push out a little bit more. Adam, do you mind actually taking the dolly track out a little bit further?
Yep.
Keep going, keep going. Keep going, keep going, keep going.
Okay.
All right, I think that's going to work. So let's start here, and Ben, while our character comes in, just keep pulling back, and then let her, as soon as she starts getting out of frame, I'm going to start craning up. All right?
Sounds great.
Sounds good. All right, let's roll camera.
Speed.
All right, ready? And 3, 2, 1, action. And dolly. All right, let's cut right there.
Cut there.
All right, nice. So, that's a really good shot, but I think the first one is a preferred one for me. So Callum, do you mind start loading up that first take back? And I just want to review it.
So one good feature that we have is that we can at any point bring back any pre-recorded animations that we have produced during the shoot, and then decide to play it back and then override any individual track that we produced. So in this particular case, Girish could choose anything he wants. He can either keep the shot the way it is, or he can reoperate any of the tracks, any of the devices, or any of the options that he chose. So let's see what he's going to do.
So Callum, you got to load it up. Let's do a playback. All right, that looks pretty good, but you know what? I actually want the sun to actually move to the left. So Adam, since you were born with the power of the sun, can you move the sun to the left, please?
All right, boss. So tell me when. Coming over.
Keep going, keep going. Up, that was pretty good. Go back a little bit. A little too much. Yeah, let's go right there. That's looking pretty nice. Okay, awesome. And Callum, do you mind switching that to a 60? I like to punch in a little bit further.
60 coming up.
Cool. And I'm going to operate the focus over here. I'm going to start a little out of focus and come into focus as we come down. All right, so let's rerun the shot.
Speed.
And 3, 2, 1, action. Awesome, let's cut right there. And that is a print. Thank you very much.
Can I still have?
Sorry, I heard cut and that was a print, so I took that as a so just a little heads up. I've noticed some of you are cheating a little bit, voting early. That's fine, but just know that you can't change your vote, so it's all locked in. Next up, we're going to have deep learning-based photoreal avatars for online virtual worlds in iOS. Presenting are Hao Li of Pinscreen and USC, Jens Forsen from Pinscreen, Jae-Woo So from Pinscreen, Koki Nagano from Pinscreen and the USC Institute for Creative Technologies, Kyle San and Aaron Hong, both of Pinscreen. Hao is CEO of Pinscreen and a professor at USC. Jens is the CTO of Pinscreen. He was one of the first employees at Unity and later worked at ILM and Imagination Technologies. Jae-Woo is Director of Engineering at Pinscreen. Previously, he worked at ILM, Weta Digital, and OLM Digital. Koki is a principal scientist at Pinscreen, and he previously worked for Weta Digital and Oculus Research. Kyle and Aaron are award-winning software engineers at Pinscreen who graduated from USC's GAME program.
All right. Hey, everyone. We are from Pinscreen, and we do digital avatars. Digital avatars are everywhere these days. They're in games, they're in VR, and we really want to do digital avatars that are photoreal. But creating that today is actually really hard. You need a full team of engineers and artists to actually get there. So what we're going to show you today is Pagan. Pagan is our photoreal avatar engine, and it can create a photoreal avatar in just one input photo. So check it out.
Yep, so this is Pagan, the face machine from hell. Let's start with a picture of Mike to build his avatar here. It takes only a second now to get his model here and the texture on it. So what is so special with Pagan? So typically in the previous pipeline, to add more details like tongue or teeth or wrinkles, it takes a lot of manual work from artists to create such details. Pagan is a new AI which generates all these details instantly online and from scratch, like this. So the system never saw the actual data of the inner mouth of Mike, but it still can synthesize realistically looking teeth, tongue, and wrinkles, and even blood flow. So now let's drive his face with our real-time camera-based face tracker. We have Koki already here tracking his face with this. And now we can transfer his expressions to Mike, seen here. And then let's render this back on the video. Here, now we have everything with tracking, synthesizing, rendering, everything running in real time along with this Pagan AI. Shall we try someone else, like our glorious leader? Yeah, looks good, looks great. Let's also try with maybe these lightings. We already demonstrated this last year, but yeah, our face tracker can track the face with all these lighting conditions, and we can see the Pagan is still creating a good job with this lighting. Can we now try someone more attractive? Here you go. Can we run this even on Canadians? Oh, it even works on Canadians. All right, so as a last example here, we would like to invite Jesse as our live subject. there? Camera.
3, 3, say neutral, 3, 2, 1.
All right, let's check it out how he looks like. Here you go. Everything working fully in real time, AI, photorealistic, from just a single picture. So this is it for our PC demo, and this is great, but we still need the power of giant like desktop GPUs to run this. Now Koki will explain how we ported this to mobile devices.
So we just saw that a Pagan can create realistic expressions and mouse interiors from just one photograph. So basically, this is half of the work is already done. With advanced compression and computed 3D head geometry and hair model, we have a complete 3D avatar running on a mobile phone, shown here. Let's take a look at the wrinkles on the forehead when you make a surprise expression. Also, if you move the mouse left and right, we have wrinkles appearing, disappearing. They are all fully generated from just one picture. So let's look at different avatar. Since this is 3D, we can rotate our head. Also, we have eye gaze. Eye gaze adds a lot more lifelike quality to the avatar. Seems pretty good. Let's check the digital mic here. The mouse is particularly hard part to do it on a mobile phone. To this end, we use nonlinear blending using additional lightweight neural network that compresses all the dynamic mouse interiors. So we can see teeth appearing, disappearing. This is a particularly challenging example, but hopefully it looks natural. So we have also a very special avatar here of Jesse. Hopefully it looks like him. Let's put it together with a customized body and CG environment. So we have a IMU sensor, so we can look around. Looks like we're in a ramen bar. And let's make him dance. So while we have control over body, also facial tracking, also the rendering, image-based rendering, everything is running on the phone. So this way we can fully immerse ourselves into a very interesting CG environment. Now Kyle and Aaron are going to talk about how this can be used in multiple avatar games.
Thanks, Koki. So being able to digitize yourself from a single input photo opens up plenty of opportunities in games, virtual reality, and other immersive experiences. So today we'll be showing you a multiplayer game demo using our avatars on the MacBook Pro. So here I am in Santa Monica Beach. Oh shoot, is that Rihanna?
No, this is Kyle from Pinscreen.
Oh, okay, so what's up, Kyle?
Check out Pinscreen's face tracker on the MacBook Pro. We can use it to hold virtual conversations and synchronize our expressions over the network. Pretty cool, right?
Yeah.
We can also change our clothes to further customize our avatars.
Hey, check out this cool dance I can do.
Yeah, so we can use face tracking and combine it with animations and emotes to further express for more expression. This is just one of many possibilities achievable with Pinscreen's avatar tech.
All right, I hope you enjoyed the demo of Pagan. Looking forward for you to check out the app that's coming out soon with the photoreal avatars. So stay tuned on pinscreen.com. Thank you.
That's what they call a face for radio. So now's the moment I warned you about earlier. Everybody get out your phones, load up the app, and start voting. Now, one warning, keep doing what you're doing. But in the spirit of real time and live, we have about 3 minutes to do this. And that includes voting and tallying. So make it quick. We couldn't get the rights to the Jeopardy theme song. So in the spirit of the Electronic Theater coming up later, we're going to go ahead and play you the trailer now so that that's going on while you're voting. But go ahead and do it. Thanks. All right, everybody get a chance to vote? Hope so. So, just so we're all clear, this little beauty is what's at stake here. And now, I think, without much further ado, thanks, Gracie. All right. Real Time Live 2018 Best of Show, according to the jury, including you guys, is democratizing mocap. Did we lose Corey? No, it's all good, buddy. All right, man.
You want to say something?
Say thanks.
Thank you. Thank you. Super awesome.
Thanks a bunch. Right, that's your Real Time Live 2018, everyone. Thanks again for participating and being a part of the show.